Imagine this. You step out of your front door, but instead of grass and trees, you're looking at a gray desert stretching endlessly under a black sky. The Earth hangs above the horizon, glowing blue and alive. This isn't science fiction. By 2040, NASA wants to build a permanent base on the moon. Homes, power plants, mining facilities, even laboratories where astronauts and one day civilians will live and work off-world. Not a camp, not a visit, a settlement. The dream of a moon base. The moon has always been humanity's first step into space, our closest neighbor, our silent companion circling Earth, and the first world where humans dared to leave their footprints. In 1969, Apollo 11 carried Neil Armstrong and Buzz Aldrin to the lunar surface, an achievement that electrified the world. For a brief moment, humanity stood beyond Earth, gazing back at the blue planet from a new vantage point. Over the next few years, 5 more Apollo missions followed, each pushing the boundaries of exploration. But by 1972, with Apollo 17, the curtain quietly fell. The astronauts returned, and no one has been back since. For decades afterward, the idea of a permanent base on the moon lived mostly in the pages of science fiction novels and concept art. Engineers sketched visions of lunar domes, astronauts dreamed of long-term outposts, and children imagined what it would be like to grow up under an alien sky. But in reality, budgets shrank, political will faded, and the technology of the time simply wasn't ready to make it happen. The dream lingered, waiting for its moment. Now, that moment has arrived. NASA's Artemis program, named after Apollo's twin sister in Greek mythology, represents not just a return, but a revolution. Artemis isn't about planting flags and leaving. It's about building, testing, and staying. Why? Because the moon offers everything humanity needs for the next leap forward. It is the perfect test bed for future Mars missions. Its shadowed craters hide water ice that could be turned into drinking water, breathable oxygen, and rocket fuel. Beneath its surface may lie valuable metals, and strategically, it is the high ground of space exploration. NASA believes that by 2040, a moon base won't be science fiction anymore. It will be reality. Why 2040? Why not sooner? Why not later? NASA's choice of 2040 isn't arbitrary. It's the year when 3 powerful timelines finally converge, creating a window where a permanent human presence on the moon becomes realistic, not just aspirational. The first timeline is technology readiness. For decades, scientists and engineers have inched forward, developing tools that once belonged only to science fiction. By the 2030s, those tools will mature. 3D printing will allow habitats to be built directly from lunar regolith, reducing the need to launch heavy materials from Earth. Robotics will handle dangerous construction in low gravity, paving landing pads, and assembling solar arrays. Compact nuclear reactors, already under development, will provide reliable power through the 2-week lunar night. Each of these innovations must work together before a base can truly thrive. The second timeline is Artemis milestones. Artemis 1 launched in 2022, proved NASA's new mega rocket could reach the moon. Artemis 2, planned for 2025, will send astronauts around it, a rehearsal for what comes next. Artemis 3, targeting 2026 to 2027, aims to put humans back on the lunar surface for the first time in over 50 years. From there, the missions will grow progressively more ambitious, delivering landers, rovers, power systems, and eventually the first modular habitats. Each step lays another brick in the foundation of a moon base. The third timeline is global partnerships. The United States isn't going alone this time. Europe, Japan, Canada, and private space companies are pooling their strengths. Together, they're shaping a shared lunar economy, from logistics to communications to scientific research. When these 3 timelines align, NASA sees 2040 as the tipping point. Not a dream, not a sketch on paper, but the dawn of a real lunar settlement. The blueprint. So what does a moon base look like? It's not just a single structure, but a carefully designed ecosystem. A small city in the making. NASA's vision is less about one base camp and more about a network of modules and systems working together to keep humans alive, productive, and sustainable on the lunar surface. At the core are the habitat modules. These won't resemble earthly houses or even the cramped Apollo landers. Instead, they may be inflatable domes or structures 3D printed directly from lunar soil. Once built, they'll be covered with thick layers of regolith to protect astronauts from cosmic radiation and micrometeorites. Inside, they'll provide living quarters, laboratories, and communal areas where astronauts can work and rest. Next come the power systems. Solar farms will likely be placed on the rims of craters near the poles, where sunlight is nearly continuous. For the long, freezing lunar night, compact nuclear reactors will step in. Steady, reliable sources of energy that ensure the base never goes dark. Life support is another cornerstone. Systems for air recycling, water purification, and waste recovery will be vital. Greenhouses filled with hydroponic crops may supply not only food, but also oxygen, creating a self-sustaining loop. Transport infrastructure will knit the base together. Rovers will ferry astronauts and cargo across the surface, while advanced landers deliver supplies from orbit. In time, even maglev-style cargo movers could link outposts across larger regions. Orbiting overhead will be the Gateway, a small space station circling the moon. It will act as the central hub, connecting Earth with the surface and serving as a staging ground for deeper missions. Unlike Apollo, where everything was carried from Earth, this new approach depends on in situ resource utilization, turning lunar soil and ice into building material, fuel, water, and air. This isn't just camping on the moon, it's the foundation of a permanent lunar city. Key takeaway number 1. Living on the moon is a step toward Mars. Why would humanity pour trillions of dollars into building homes and habitats on a barren, airless rock only 384,000 kilometers away? The answer is simple. The moon is a proving ground, a training arena for the far more ambitious journey to Mars. Mars is not just farther, it's a world apart in terms of risk. At its closest approach, the red planet is still about 55 million kilometers away. A crewed trip would take 6 to 9 months each way. That means no quick rescue, no emergency supply drops, and no fast return if systems fail. On the moon, however, the situation is different. It's just 3 days from Earth. If something goes wrong, a life support failure, a power outage, or even a medical emergency can help arrive in time. This makes the moon the ideal stepping stone for testing the technologies and strategies humanity will need for deep space missions. Living there forces us to solve problems we cannot avoid. Building with local materials. 3D printing with lunar regolith teaches us how to construct without Earth's supply chain. Surviving extreme radiation. Shielding and underground habitats tested on the moon will later protect astronauts on Mars. Growing food in hostile environments. Greenhouses in lunar soil and hydroponic farms will be prototypes for Martian agriculture. Every challenge on the moon echoes a greater challenge on Mars. By mastering them in Earth's cosmic backyard, we increase our chances of survival when we take the next leap outward. The moon, in this sense, is not a destination. It is the launch pad, humanity's sandbox, laboratory, and rehearsal stage for becoming a truly interplanetary species. Building materials. Here's where it gets wild. Future moon bases won't be shipped from Earth like oversized Lego sets. Instead, NASA and its partners plan to build them directly out of the moon itself by 3D printing habitats from lunar dust. That dust, known as lunar regolith, is more than just a nuisance clinging to astronaut boots. It's a construction material waiting to be unlocked. The fine gray powder is made of crushed rock and glass, created by billions of years of meteor impacts. Scientists have discovered that it can be melted into bricks using intense heat from microwaves or lasers, or hardened with chemical binding agents. Companies like Icon which already prints entire houses on Earth using massive robotic printers, are adapting the same technology for the Moon. Imagine giant 3D printers laying down layers of regolith like frosting, slowly forming domes, walls, and even landing pads strong enough to withstand rocket exhaust. The process is fully robotic, meaning construction can begin years before humans ever set foot on the base. This approach solves two critical problems. The first is the transport cost. Every kilogram launched from Earth costs thousands of dollars. Shipping concrete, steel, or pre-built modules across 384,000 kilometers is simply unsustainable. But if the Moon itself provides the raw material, the cost drops dramatically. The second is radiation protection. The Moon has no atmosphere and no magnetic field to shield life from cosmic rays or solar storms. Thick walls made of regolith, meters deep, could provide the safety astronauts need to live long-term without constant exposure. So picture this: autonomous robots landing first, quietly working for years, printing habitats out of dust. Then when the first human crew arrives, their homes are already waiting, built not by hand, but by machine, from the very ground they stand on. Key takeaway number 2: the Moon base as humanity's first off-world colony. The International Space Station gave humanity its first permanent outpost in orbit. For over 2 decades, astronauts from dozens of nations have lived and worked together, circling Earth every 90 minutes. But while the ISS floats just 400 kilometers above us, it is still tethered to Earth, resupplied by regular cargo missions, protected by our planet's magnetic shield, and always within a few hours of home. The Moon base will be different. It will be the first true human settlement beyond Earth's surface. For the first time in history, people will not just visit space for weeks or months at a time, they will live there, year-round. They will sleep under a sky with no atmosphere. They will harvest food grown in artificial greenhouses lit by LED panels. They will drink water extracted from lunar ice and breathe oxygen made from the very soil beneath their feet. That changes everything. Politically, it will mark the beginning of a new era of international cooperation or competition, on a scale we've never seen before. Scientifically, it will provide laboratories unlike any on Earth, where experiments can run for years in low gravity, extreme cold, and deep space radiation. Psychologically, it may reshape how humanity sees itself, no longer confined to one planet, but finally becoming a multi-world species. The shift is more than symbolic. It means that humanity will have proven the ability to sustain life on Earth, not just with supply chains, but with local resources. The Moon base will stand as the first colony, small at first, but expanding year by year. It's not just visiting space, it's living there. Power and resources. The Moon is a place of extremes. No breathable air, almost no liquid water. Daytime temperatures are hot enough to boil metal, and nights are cold enough to freeze steel. For a human settlement to survive there, every essential resource must either be produced locally or recycled with extreme efficiency. The question isn't just how we bring supplies from Earth, it's how we make the Moon work for us. The first timeline is water ice. In the permanently shadowed craters near the lunar poles, where sunlight has not touched for billions of years, vast reserves of frozen water lie hidden. This ice is priceless. Once mined, it can be purified into drinking water, split into oxygen for breathing, and hydrogen for rocket fuel. In effect, water ice is the foundation of a lunar economy, the source that makes everything else possible. Next is energy. Power is the heartbeat of any settlement. Along the rims of polar craters, sunlight can shine almost continuously. Vast solar farms can capture that energy, feeding habitats, greenhouses, and machinery. But when the long lunar night falls nearly 2 Earth weeks of darkness, solar power won't be enough. That's where mini nuclear reactors, like NASA's Kilopower project, come in. Compact, safe, and steady, they could keep the base alive when the sun disappears. Then there's oxygen. Remarkably, lunar soil itself is rich in it. Regolith contains up to 40% oxygen by weight, locked in oxides. With the right technology, oxygen can be extracted, not only to breathe, but also to burn as rocket fuel. Finally, food. Greenhouses will recycle water, use hydroponics to grow crops, and provide astronauts with fresh produce. Artificial lighting will mimic Earth's sun, turning barren modules into gardens. The key to survival is self-sufficiency, reducing costly resupply missions from Earth and transforming the Moon from a wasteland into a life-supporting world. Challenges and risks. This isn't easy. Building a permanent base on the Moon isn't just an engineering puzzle, it's a survival trial, filled with dangers both known and unknown. The first is radiation. With no protective atmosphere or magnetic field, the Moon is constantly bombarded by cosmic rays and solar storms. A major flare from the Sun could be deadly if astronauts are caught outside or unshielded. Thick walls of regolith and underground habitats may offer protection, but radiation exposure will always be a risk. Then there's the problem of dust. Lunar regolith looks soft in photos, but under a microscope, it's razor sharp. The result of billions of years of micrometeorite impacts. It clings to everything: spacesuits, tools, machines, and once inside, it can shred lungs, scratch visors, and wear down seals. Apollo astronauts described it as smelling like burnt gunpowder, and it remains one of the most underestimated hazards. Temperature is another relentless enemy. In sunlight, the surface can reach a scorching 120+ degrees Celsius. In darkness, it plummets to minus 170 degrees Celsius. Electronics, machinery, and habitats must endure cycles that would destroy most Earth-built systems. On top of that are logistics. Every gram of food, medicine, and spare parts must be planned months in advance. A missing tool or delayed shipment could mean catastrophe. Unlike the ISS, where cargo arrives regularly, lunar resupply will be costly and infrequent. And finally, isolation. Astronauts will live in confined modules for months, cut off from Earth except for delayed communications. The psychological toll of separation, monotony, and high stakes will test even the most resilient crews. And beyond all these challenges lies the greatest threat: the unknowns. Hazards we can't predict until humans are there, living day by day on a hostile world. Key takeaway number 3. Permanent presence changes everything. Once humanity establishes a permanent base on the Moon, the game changes forever. It's not just about planting another flag or running short-term experiments. A permanent lunar presence will transform science, industry, and geopolitics in ways we are only beginning to imagine. For science, the benefits are immediate. Telescopes placed on the far side of the Moon, shielded from Earth's atmosphere and radio interference, could peer deeper into the universe than ever before. Laboratories in low gravity would allow experiments impossible on Earth, from studying human biology in long-term reduced gravity to manufacturing materials with properties that could revolutionize technology. But where science leads, industry follows. The Moon is rich in resources, from rare metals essential for electronics to water ice that can be converted into fuel. One of the most intriguing possibilities is helium-3, a rare isotope embedded in lunar soil by the solar wind. On Earth, it's scarce, but on the Moon, it's abundant, and some scientists believe it could be the key to future fusion power. If that technology matures, helium-3 mining could turn the Moon into the Saudi Arabia of clean energy. And then there is politics. Who owns lunar land? Who controls its resources? The Outer Space Treaty of 1967 prohibits nations from claiming territory in space, but it never anticipated private corporations, multinational consortia, or the possibility of long-term colonies. Already, countries and companies are eyeing the Moon as a strategic high ground, both literally and economically. The result? The Moon could become the 21st century version of the New World, a contested frontier, a driver of wealth, and a reshaper of global power. Once we stay, we don't just change the Moon. we change Earth's future too. The 2040 vision. Picture this. It's the year 2040. The moon is no longer a distant symbol of human ambition, but a lived reality. Astronauts wake up in regolith-domed habitats, their walls built from the very dust they stand on. Morning routines include checking solar farms stretched across crater rims, monitoring compact nuclear reactors, and tending to greenhouses where hydroponic crops grow under soft LED light. Lettuce, tomatoes, and wheat sway gently in controlled air, the first harvests from a world that once seemed barren. Outside, rovers wait, ready to carry crews across gray plains to explore lava tubes, drill for ice, or test construction techniques for larger settlements. On Earth, school children crowd around classroom screens, watching live feeds of lunar sunrises, as naturally as previous generations watched the weather report. The moon has become part of everyday life. Meanwhile, the first wave of space tourism is underway. Wealthy adventurers book tickets for civilian flybys, with whispers of surface tours to come. Cargo ships make regular stops at lunar fuel depots, topping off with water-derived hydrogen before venturing toward Mars or the asteroid belt. Step by step, the moon has evolved into humanity's first great spaceport. The political landscape shifts as well. Nations and corporations share, compete, and negotiate over mining rights, scientific zones, and tourism corridors. What once was a silent rock has become a stage for human cooperation and rivalry alike. And through it all, a deeper truth takes hold. The moon isn't just a rock in the sky anymore. It's humanity's second home, a foothold in space, a stepping stone to Mars, and a constant reminder that our destiny lies beyond Earth. By 2040, the moon base could be humanity's boldest step since fire, flight, and the internet. It won't be easy, it won't be cheap, but if NASA and its partners succeed, it will mean one thing. For the first time in history, Earth will no longer be the only place we live. Subscribe for more future space explorations and tell us in the comments, would you take the one-way trip to join the first lunar settlers? Stay blessed and stay curious.